In this video, we're going to be looking at the first of several examples of stoichiometry. Now, stoichiometry tells us about how the amounts of reactants consumed in a reaction is related to the amount of products that are produced. Now, when you look at the chemical equations, you want to remember that this tells us about the moles of the reactants and the products. So this particular equation tells us that when 1 mole of chlorine reacts with 3 moles of fluorine, it produces 2 moles of chlorine trifluoride. So the equation doesn't tell us about mass, it tells us about the moles. So we can convert between the moles of one compound involved in the reaction with the moles of any other compound involved in the reaction by using the coefficients in the reaction as a conversion factor. If we happen to be given the amounts of a compound in grams, I would need to convert back and forth between the mass and the moles using the molar mass of that compound. So whenever we're doing stoichiometry, we always want to get our quantities into moles before we convert between the different compounds, and then once we've done that conversion, we can go back into the grams of the new compound if that's what we're asked for. So in the first example on this video, we want to know how many moles of chlorine trifluoride can be produced from the reaction of 0.563 moles of fluorine. And we're told that chlorine is in excess. So in this case, we're only worried about converting between the amount of fluorine consumed and the amount of chlorine trifluoride that's produced. So if we're already given our quantity of fluorine in moles, this problem is relatively simple. I just need to convert between moles of fluorine and moles of chlorine trifluoride. So the conversion factor that I'm going to want to use comes from the equation. So the coefficient in front of the fluorine is a 3, so that means that 3 moles of fluorine are going to produce 2 moles of chlorine trifluoride. So using that conversion, it's very easy then to convert between the amount of fluorine that's reacted to the amount of chlorine trifluoride that's produced. And so to do that, it would look like any other conversion factor we've done. I've got 0.563 moles of fluorine. So I would put 3 moles of F2 in the denominator, so it cancels with the moles of fluorine that I started with. That's equivalent to 2 moles of ClF3. So our moles of fluorine will cancel with moles of fluorine. We'll be left with moles of chlorine trifluoride. And so when I multiply that out, my result is 0.375 moles of ClF3. Alright, this problem is similar to the last one. Only in this case, we want to know about what mass of chlorine trifluoride can be produced. Whereas in the previous problem, we were asked about the moles. And instead of being given the moles of fluorine, we're given the mass of chlorine. So before I can convert between the chlorine and the chlorine trifluoride, I need to get the mass of chlorine into moles. And then once I have the moles of chlorine trifluoride, I need to get the moles into a mass. So I'm going to need the molar masses of this reactant and this product. So the molar mass of Cl2 is simply 2 times the molar mass of chlorine. So that means that the molar mass of chlorine is 70.90 grams per mole. Or I can write that as 1 mole of Cl2 is equivalent to 70.90 grams. And I would do the same thing for the product. So the molar mass of chlorine trifluoride is 1 chlorine plus 3 fluorines, and I get a value of 92.45 grams per mole. Or another way to say that is that 1 mole of ClF3 is equivalent to 92.45 grams. And then we put Cl2 up here and ClF3 down here. So I have two of my conversion factors. I can get from mass of chlorine into moles of chlorine using this one. I can get from mass of chlorine trifluoride into moles of chlorine trifluoride, or vice versa, using that conversion. And to convert between chlorine and chlorine trifluoride, I use the coefficients for my balanced chemical equation. So I can say that 1 mole of chlorine is equivalent to 2 moles of ClF3. So now that I have my three conversion factors, I can go ahead and convert between 25 grams of chlorine into the mass of chlorine trifluoride. Alright, so let's see what that would look like. So I'm starting with grams of chlorine, so I need to use this conversion factor first. So I'll put 70.90 grams of chlorine in the denominator. And that's equivalent to 1 mole of Cl2. So at this point in the problem, I've converted between grams of chlorine into moles of chlorine. Now I'm ready to go from moles of chlorine to moles of chlorine trifluoride. So I will use this conversion factor. And so 1 mole of Cl2 is equivalent to 2 moles of ClF3. Alright, at this point I now have moles of chlorine trifluoride, so I'm ready to convert that into the mass that the problem asks for. So I would use this conversion factor. And so 1 mole of ClF3 is equivalent to 92.45 grams of ClF3. If I check my units, my grams of chlorine cancel with grams of chlorine, moles of chlorine cancel with moles of chlorine, moles of ClF3 cancel with moles of ClF3, and so I'm left with units of grams of chlorine trifluoride. Grams are a unit of mass, so that's a good indication that I've set everything up correctly. And when I multiply all of that out, the result that I get is 65.2 grams of ClF3. Okay, I have one last example related to this chemical equation. In this case, I want to convert between two reactants as opposed to a reactant and a product as I did before. Remember that I can do the conversion between the amounts of any reactant and any product, or any two reactants or any two products. So in this case, I want to know how many grams of chlorine would be required to completely react with 15 grams of fluorine. So this will look just like the last problem. I'll just be going from fluorine to chlorine. Alright, so I'm going to need the molar mass of both of these reactants because they are asking about the masses of each one. So I'll need to go from mass to moles. So from the previous problem, I know that 1 mole of chlorine is equivalent to 70.90 grams of chlorine. All right, to get the molar mass of F2, which is 2 times fluorine, so 2 times 19 would be 38. So 1 mole of F2 is 38.00 grams of F2. And then the other conversion I need is the mole-to-mole conversion, right? And so I'm going to use that 1 mole of chlorine is equivalent to 3 moles of fluorine. So I have that 1 mole of Cl2 is equivalent to 3 moles of F2. So now I'm ready to set up the conversion. So I'm starting with 15 grams of fluorine. And now I'll use that 1 mole of fluorine is equivalent to 38 grams. At this point in the problem, I've converted the grams of fluorine to moles of fluorine. So now I want to go from moles of fluorine to moles of chlorine. So I'll use this one next. So I've got 3 moles of F2 is equivalent to 1 mole of Cl2. At this point in the problem, I now have moles of chlorine. The problem asks about the grams of chlorine, so I want to convert to that using my first conversion factor. So I know that 1 mole of Cl2 is equivalent to 70.90 grams of Cl2. And so I'll multiply everything across the numerator, multiply everything across the denominator, divide those two, and the result that I get is 9.33 grams of Cl2. And that is our final result.